Hi, good afternoon. In our last lesson, we learned about different energies such as kinetic and potential energy. Today we are going to explore one of the most fundamental laws in physics, the law of conservation of energy. So in today's class, students will be able to ask questions and predict outcome about the changes in energy that occur when objects collide. Students will be able to understand that energy can neither be created nor destroyed. It is transferred. So let's start our lesson by watching a video that will introduce us to this important concept. Bubble, we have to pause this. Let me make it a little louder so everyone can hear. Also turn on the caption.
Guys, who likes a good game of bowling on a Friday night?
I like bowling.
I love bowling. Just stay there a sec. Just get this bowling ball. Dom, just hold that. Well, I just set up here with a dinosaur. Just watch the dinosaur and see how much he likes bowling.
Okay.
Oh,
dinosaur.
Yeah, anyway, Dom, could you just stand here for me?
No.
Yeah, please, just Dom, just come and stand. I just want you to hold this.
Okay, I'll hold
just
it, yeah.
stand there, hold that.
Yeah.
Okay. I want to demonstrate a fundamental principle of physics known as the conservation of energy. The fact that energy cannot be created or destroyed. Okay. Can you pull that up to your nose? That's it. Right up to your nose. That's it. Put your head up straight. And, all right, let's go chin.
All right.
That's good. Just there. Now, Dom. When you let go of it, some of that energy is going to be converted to moving energy or kinetic energy, okay, as it starts to move. Okay, then it's going to keep going all the way up to the other end of its arc, where it then gets back to having maximum potential. Back down again, maximum kinetic, up to the top, maximum potential.
Great.
So I'd like you to release the ball.
Are you serious?
Yeah.
What now?
In the name of science, Dom.
Are you holding my head in case it hurts?
Yes.
Great, I'm scared.
And let go. Hands down.
I don't like that.
Amazing!
Whoa.
How good is that?
It's frightening.
Fran, hold that one for me, can you? Wow, that's genuinely going. Did you enjoy that?
No.
The ball could never have bashed Dom's lovely face in because energy cannot be created or destroyed. It could only swing back to where it came from. So, if you try this, be careful not to give it an extra push.
How come you did kill the dinosaur? You didn't kill my face?
I cheated a little bit. As I let go of the ball that time, I pushed it a bit. So I put some more energy into the system so it could get a bit higher and wipe out the dino. But luckily, your little face is all good.
Okay, that's the end. Let me go back. So let's discuss about this video. Who can tell me what's the main idea from the video? What is the law of conservation of energy? Okay, yes, Eric.
Well, the main idea is that energy is not lost because it came back where it started.
Oh, yes, excellent. So, you're right. So, the law of conservation of energy actually states two principles. So, the first principle is that energy cannot be created or destroyed. It is always conserved in the universe. The second principle is that energy can be transferred from one object to another or transformed from one type to another. For example, when you flip a light switch, electricity flows from the wall into the light bulb. Inside the light bulb, there's a tiny wire called filament. It's right here. When electricity goes through this wire, it gets so hot that it glows and gives off light. The electricity changes into light energy. The energy changes its form, so you can see it in the dark. Alright, if you have any questions?
What is the wire made of?
The wire filament is made out of a metal called tungsten. All right, so Now I'm going to hand out this worksheet and I'm going to let you to think about this. So when you catch a moving ball, what happens to the kinetic energy? Why does the ball just stop moving? Where did the energy go? And what happens when your hand and the ball collide? So I'm going to demonstrate this activity with a ball here. Eric, could you please stand up? I would like you to gently toss the ball to me and think about what's happening to the energy and also think about the questions on the worksheet. All right, so now after this demonstration, you can jot down what you observe in the box below. You're going to have 3 minutes for this. If you have any questions, you can always raise a quiet hand. And if you are done earlier, you can also raise a quiet hand and let me know. Oh yes, I remember. Okay. So I'm gonna pause the timer and we can go back to my slideshow. So would you like to share what you put down here?
The energy from the ball went into my hand, and there's no energy in the ball, so it stopped. That's why it stopped. The kinetic energy went into the hand, and the ball and the hand collide. That's when the hand takes the energy from the ball.
That's an excellent question. Yes, you mentioned about kinetic energy. I want to know, what if you didn't catch the ball? Like, what happened to the ball?
I think it will keep moving.
Actually, the ball will eventually stop because it will keep moving until friction and gravity eventually stops it. There's also always like outside forces like friction and gravity. So let's learn about the science behind what we just demonstrated. So I'm going to talk about energy transfer. If energy can neither be created or destroyed, where does the energy go when you catch a moving ball? When two things collide with each other, they exchange energy. The energy is either transferred to or it is transformed. When you catch a moving ball, kinetic energy is transferred to your hand. That's why your hand may move back when you catch the ball. Imagine if someone threw a bowling ball at you. When you go bowling, you roll the ball down the lane, giving it kinetic energy. When the ball collides with the pin, the energy is transferred and the pin falls over. Objects also tend to make a sound when they collide, just like when a ball hits the ground or when you clap your hands. This is because some of the energy is transferred into the air and transformed into sound energy. So anything that has mass and velocity has kinetic energy. So what is velocity? Velocity is the quickness of motion. The heavier your car and the faster you're going, the more kinetic energy the car has. If you stop the car suddenly, the passengers will keep moving forward until the energy is transferred or converted. If the car collides with something, the energy is transferred to the object it collided with, and the passenger's energy will also move forward until transferred or converted. Therefore, safety features such as seatbelts and airbags were invented to help passengers safe in a collision. If you have ever experienced a collision, you will have noticed that you were jolted forward and your seatbelt held you back.
Why do you move forward in collision?
You move forward in collision because the car is moving at a very fast speed, and when you are in the car, you're also moving at a very fast speed with the car. So when the car struck onto something that sits still or like that's static, there's no time for the car or yourself in the car to react to that force. That's why you move back. Do you have any more questions? Did I explain it clearly? Okay.
Yes.
So, we are going to explore what happens when objects collide with the activity called crush the sugar cube. So you will explore what happens when a battery collides with a sugar cube. Your challenge will be to design a protective coat for the sugar cube to prevent it from breaking. So for this experiment, you'll need one kitchen roll tube, one toilet roll tube, one D-cell battery, some bubble wrap, and sugar cubes. I'm also going to give you a piece of black paper so that you can get all the sugar particles if the sugar cube actually crushed. So this is what I'm going to do. I'm going to put the sugar cube on this piece of black paper. And I'm going to start with the toilet roll tube. I'm going to cover it like this. And now I'm going to hold the D2 cell battery and I'm going to drop the battery and we'll see what happens. And I'm going to take it down. See? So now I see a lot of sugar particles here on this piece of paper. I'm just going to bring it a little closer for you guys to see. I want you to try it with the kitchen roll tube and also the toilet roll tube. You can try it with the paper wrap, without the bubble wrap or with the bubble wrap. I want you to be creative and see how can you design the most effective way to protect the sugar cube from crashing. Alright, it's your time to try and you will have 10 minutes for this. Here you go, here's a worksheet that you can put down all the information here. I'm going to set up the timer. What do you think will happen even when you didn't do anything?
I think that the kitchen roll tube will crush it more.
That's a worry. Yeah, that's a very excellent prediction. Now you can try and let's test if your prediction is correct. Okay, I'm going to start the timer. Make sure that you hold the tube. So this is the amount of particle that you get with the bubble wrap. Oh, you put 3 layers of bubble wrap on top of the sugar cube. Just gonna bring it a little closer for you guys to see. All right. That's a lot of sugar particles. You dump out all the things on the paper wrap. Okay, there's. So when you use the toilet roll tube, there's less sugar particles compared to when you will use the paper towel roll tube. You can be creative. You can design how you're going to wrap the sugar cube with your bubble wrap and see which one gives you less sugar particle. This time you get less sugar particles compared to the first time you try. Plus, this time we can make it sugar particles. We have 5 more minutes. Now, what should two particle this time? Oh, is that with a bubble wrap? Wow, a lot of sugar particles here. I noticed that you try it multiple times with the paper towel roll too. Would you like to try it with the toilet paper roll too?
Okay.
That's sugar particle. I wonder why. You have 3 more minutes left to try. That's sugar particle. That's a very creative way. You fold it like a triangle and you put it on top of the sugar cube.
Yeah.
Oh, it barely made any sound. Is there a sugar particle there?
Yeah.
Just a little bit, just some. You barely can see any. Feel free to jot down your observations while you're doing the experiment so you don't forget. Just going to bring it a little closer for you guys to see. more seconds. Barely no particles this time. Time's up. If you need any more time, I can give you 2 extra minutes. You can jot down your notes on the worksheet, your observations as well. If you have any question or you're all done, you can always raise a quiet hand and let Michelle know. Alright, you're done? Okay, I'm going to press the timer. I'm just going to go back to the slideshow that I have. Okay, so would you like to share anything that you put down here on the worksheet?
So my observation about this experiment is that the kitchen roll without bubble wrap had the most sugar particle, and then the toilet roll with bubble wrap had the least sugar particle, and then the kitchen roll with bubble wrap had the second most sugar particle, and then the toilet roll without bubble wrap. The toilet roll without bubble wrap had number 2 greatest sugar particle, and then the kitchen roll with bubble wrap had number 3 sugar particle.
So from what I've heard from you, the one with the kitchen roll 2 with sugar cube that has no bubble wrap has the most sugar particle, right? And then the toilet roll 2 with the sugar cube without bubble wrap has the second to last most sugar particles on a piece of paper.
Second most.
Second most, okay. And then the toilet roll 2 with bubble wrap has less sugar particle when you drop the D2 battery on it, right?
Yes.
Okay. Yeah. That's a very good observation. So do you know why did that happen? Why the ones that has bubble wrap around it has less sugar particle when the battery is struck on it?
There's a lot of layer which stop the battery.
That's actually correct because there are a lot of layers of bubble wrap, so it slows down the energy transfer process, which gives the sugar cube more time to protect itself. All right, we are going to discuss the science about this after we watch this YouTube video.
I'm Dr. Jeff Vinegar, and today
I'm just gonna pause this and make the screen a little larger and also turn on the caption.
we'll explore the science behind the energy of moving objects. We're going to demonstrate a type of energy transfer called a collision. It's when one object runs into another object. Izzy, you're going to be our stationary object, which means you're just going to stand there. Mom, you're going to be our moving object. You're going to run into Izzy on the other side of the gym.
Okay.
Team, any thoughts on what's going to happen?
I think that when Dr. Jeff's mom runs into Izzy, he'll fly back and she'll stay in place.
I think we'll both fly back.
Let's find out. Ready? Set? Go! So, you were right. We just saw the transfer of energy by a moving object, and it happened when the two objects collided. The energy of one was transferred to the other. That's why one stopped moving and the other one started moving.
Hey kids, you want to watch this whole episode and more? Tell your teacher to sign up at Generation U.
All right. So as we can see from the video, when two objects collide, the energy gets transferred to another object. So it's the same for the crush the sugar cube experiment. If you drop the sugar cube down from the paper towel roll, this is like a longer roll, the sugar cube, it falls farther, so it has more time to speed up due to gravity. And when the battery hits the bottom with, the battery will hit the bottom with more energy and might break the sugar cube or crack the sugar cube. But then for the toilet paper tube, because it's shorter in distance, which is the height, the sugar cube doesn't fall. The sugar cube doesn't fall as far, so it doesn't speed up. The battery doesn't fall as far, so it doesn't speed up as much. It hits the bottom with less energy, and it is more likely to stay intact. That's why you will see less sugar particle when you drop the D2 battery onto this toilet paper roll tube. That's because speed is actually equal to distance divided by time. Speed is how fast something moves, like miles per hour when you drive the car, and distance is how far something travels, and time is how long it takes. So if the if the paper towel roll tube is longer, that means the speed is greater, which means that the amount of energy gets transferred will be larger. But then for this one, because it's shorter, the speed is less, and then the amount of energy transfer is less as well.
So the longer tube will hit the sugar cube with more energy. So there are more sugar particles.
Yes, that's correct. But you can also think about it another way, because last lesson we learned about potential energy, right? Potential energy, this is something that you will learn in future when you go to like a higher grade. Potential energy is actually equal to mass times gravity times height. So we know that the mass of this D2 battery will stay the same. Mass is just like the weight of this object. And then the gravity is always the same because we are in the same space. Then the height is the only variable that's going to change. So the height can affect the amount of sugar cube particle that you get on that piece of paper.
So why does more potential energy equal more kinetic, more energy in total?
So the more potential energy that you have means the more kinetic energy that you have.
Oh. Okay.
Alright, did I explain everything clear?
Yes.
Okay, so now I would like you to reflect on what you learned today. You can draw a picture of your protective design from today's task, and you can also use helpful vocabulary listed down here on the worksheet to help you explain why your idea worked or didn't work. You have 5 minutes for this. If you finish a little early, then feel free to raise your hand. But if you didn't finish, you can finish up at home. Oh, you're all done. Alright. It should be go time. Would you like to share what you put down for your reflection?
My idea worked because I had a lot of layers of bubble wrap, which had a lot of protection, and then it reduced the impact of the D-cell battery. It was like less energy hitting the sugar cube because the bubble wrap like took the energy first, so it didn't hit the sugar cube.
Alright, that's a good reflection. So why are we learning about this? Why are we learning about this topic? How can we use it in real life?
I think we can use this in real life. Like the cars,
Mm-hmm.
the airbag, and then some other stuff.
Yes, actually that's right. So if you are driving a car, when you are in a car, it's related to the seatbelt and also the airbag. So airbag actually slows down the energy transfer, which means it gives you more time for you to hit a car, so the average force will become less and giving the person's body more time to stop safely. Or do you have any more questions for today's lesson?
No.
Alright, then I will see you tomorrow.
Bye.
Bye, have a good day.